All right, welcome back to our study of OOP, Object-Oriented Programming. There are some more things that I want to talk about. So just to make sure we're all on the same page, some of the topics today may be a review depending on where you took your CSCI 40, but there are some things with the statistician class that we did not do that maybe you were screaming in your mind that you know about, like a constructor or something. That's what today is for, at least partially. So let's get started there. Before we go and talk about code and C++, I do want to talk about your Zybooks assignment. So please make sure to be going out to the Assignments tab. Click the table of contents to see all the sections I'm asking you to complete for a certain assignment. For example, I just clicked on the Chapter 1 assignment on Zybooks, and it took me to the first section, but I'm asking you to read more than just 1.1. All right, I want to make sure that you can see where all of the see where the list is of all the things I'm asking you to read. And so what you do is you click the name of the book up on the top there, and that will take you, at least for me, it takes me right back out to the table of contents, and it has already selected that particular assignment, which is perfect. So these are all the sections I'm asking you to complete for this assignment. This may change in a future semester if they add more sections or something, but like these are the sections I'm asking you to complete right now, and it should tell you your current score and the score that's out of. For me, it's as the teacher, it doesn't show you my score because I don't get a score, but for you, it should show you yours, okay? And you can always click back out to look at all of the assignments that I've come up with for the class. They're all available right now if you'd like to get started and read early, but do keep in mind that only the Canvas dates are the real due dates. The due dates in the Zybooks book itself on the website, these are just the last day that I want late work to be transferred over to Canvas. So like these are not real due dates, none of these, all right? So please look at the Canvas due dates and trust those only. Okay, these are just to make sure late work transfers properly, because iBooks is a little weird, but the section list is correct. All right, so look at this for the section and for your current score, and it should just keep on automatically transferring your grade to Canvas. Sometimes you might have to click submit, but I don't think that should come up very often in this class. They're getting better at it. So iBooks and Canvas, they don't play too nicely together, but every semester they get a little better. All right, so yeah, just keep that in mind. And I want to start us off with some questions. So please pause the video and take a look at this question and see if you can figure out the right answer. All right, so at a minimum, let's say that I've got this code. Who cares what the conditions are? It's an if else, if else. At a minimum, how many test cases do you think we should have for this code? Try to think about that. What do you think? Let's get my little virtual pen ready. I think the answer is going to be 3. Do you agree? Do you see why? Because with an if else, it's always going to be one of these bodies that runs, right? Just one. It's always one or the other, right? This one or this one or this one, never any combination, right? It's always just going to be one. It picks the first one that works. Otherwise, it goes to the else, right? And so it's 3 potential bodies that are going to be run. And so for this code, at a minimum, we should have at least 3 test cases, one to hit each of those bodies, okay? It's possible that some of these conditions might be a little weird. There might be a couple different ways to hit each body, and then you'd have to add more tests. But at a minimum, a 3 test case test suite is probably a good starting point. All right, I hope that makes sense. So that's my first question for us. And then here's another one. Let's say we've got 2 things we want to do. We got 2 programs that we want to make. The first program is the idea of like, I want to sum up n numbers. Like I want to sum the numbers from 1 to n. So like if n is 5, you want to add up 1 plus 2 plus 3 plus 4 plus 5. Like you want to do that. That's option A. All right. And then option B is I want to draw a box of stars of width n. So for example, this would be a width 3 box that you'd print out to the screen. All right. And so my question for you is, this is getting us ready to start analyzing programs in a very technical way. What do you think is going to take longer as this big N goes to infinity? As N gets bigger, how much, which of these programs takes more work? What do you think? All right. So a good place to start would always be like, think about how the program's going to look. You'd probably have a loop for A for sure, right? You'd start off a sum variable, but then really deep down your loop is just adding into the sum variable a number at each round. So like it's going from 1 to 2 to 3 all the way to n, and it's adding in the next number each time. So it's kind of the question is how many pluses am I doing? And it's going to be n. You're adding in n kind of things, right? If you want to start the sum at 1, that might make it slightly more efficient. Who knows? But There's also a formula for summing up the first n numbers, but pretend you don't know which of the numbers you get. But something like that, you're going to have to do about n plus operations. Does that make sense? Maybe n minus 1 if you're careful. Or you could do a formula, who knows? If it's like an easy thing that you're given, if it's just like the numbers 1 to n, you know that there's like a special formula for that. So that's option A. Pretend you were just doing in a loop a bunch of pluses. But option B, you see how it'd be like the bottleneck is those n pluses that you got to do kind of. For option B, do you see that a width 3 box, like if this is n equals 3, how many stars are you drawing? You're drawing 9, right? So every time you print a star, it's kind of like a cout statement. So you're drawing n times n equals n squared, right? N squared stars that you're printing out. Does that make sense? And so like you're saying cout in a loop, n times, yeah? N squared times. Whereas in a loop here, we're just adding up numbers n times. So that's like n pluses versus n squared couts. I think this one's going to take more. You see that? Take more time. You got kind of another factor, another multiplicative factor of n of things to do. Does that make sense? So please yell at me if that's not super clear, but that's kind of the difference. You see how this is just naturally more work. Instead of doing n things, like you're adding up n different numbers into a sum variable, this is doing n squared things. N squared couts of a single star. And then also worrying about a bunch of new lines. That's different, right? So we want to learn how to get good at that. And practice makes perfect, okay? So let's start with, let's go back to, as our first foray back into code, let's start with constructors. Let's go back to classes and figure out how to initialize ourselves immediately. All right, because what we did last time, if I quickly go to our pacemaker, lecture 1 pacemaker classes.cpp, what I did, just because I was leading us into this, is I made sure to make an init method for us. Like, and we had to remember to always call init. Yeah, that would initialize our statistician object to be whatever it needed to be, get all those member variables where they needed to go into the right places. Wouldn't it be nice if we didn't have to deal with that? That's what a constructor's for. And initializer lists are a special way of using constructors to do some things that are necessary, all right? Some things you can't do without them. So here is my silly example for the day. We're going to make a counting device, all right? We're going to make one of these little guys where we're going to have this as a program, this as a class, like a class called counter C, semicolon, makes one of these virtually in code. And what we want is, what kind of data and operations do we need? Well, we're going to need like the deep down number that's on the counting device. Deep down. We would need a button to increment the counter to like +1 it, right, to get to the next number. And we also need this little wheel that we can spin to zero it back out. Yeah, we need all that. And then also, because we're going to be good object-oriented programmers and use access control, public and private, we don't want the user just looking at the int that's this number. Let's give them a getter to actually like look at the screen, right? So I think the one piece of data we need is just the number that's on our counter. We'll call it count. Okay, and it's going to start at 0, of course. And you can probably see that, but those look like two n's to me. So let me fix that. That's supposed to be a u. That's supposed to be an n. Well, that looks slightly different now. Okay, so like that's what I want. Every time I make a counter object, I want a count member variable, and I want to initialize it to 0. And let's do that init method again, but we're going to make it better every time. We're going to improve upon this. We're going to use constructors, all right? So here's the operations I want on my counting device. I want to be able to init, which we're sadly going to have to remember to always call it first to make sure that our count is initialized properly. We're going to have an inc method to like up the count, a reset to spin the wheel, make the count back to 0, a get count to look at the screen, see what the number is, and then our count member variable will be private, all right? It'll be private so the user can't just be like, you know what, I want to increment the count by 5 this time. Whereas really we want to model this guy where you have to click the thing 5 times if you want it to go up by 5. So let's make that happen. Let's make a counting class, and I think I'll just do this all in one file again. So let's do a file called counter.cpp. So what I'd like is, I want to do something like this. I want to say, give me a counter C, and I want to initialize C, c.init. All right, I want to make sure it's initialized. Let's just pretend we got all the right things. And then I want to call inc a few times on c.inc. So like the count, oops. Count is 0 after the init, then 1, 2, 3. The count is now 3, yeah? So if I print C, if I ask C to give me back the count, look at the window, get count, I should get back and print 3 there. And then let's make a reset method. And let's say that reset means you can like spin the dial to whatever number you want it to be. How about that? So we can say c.reset to be like 42. That would work. And or let's have it just zero it out at the start. We'll work up to that, and then we'll do c.inc, and then so the count should be like 1 now. Yeah, let's do that. And so to make like this is my template. This is what I want. Let us make a class counter now that lets this happen. So all right, I got public things that I want the user like in main to be able to use, and then I got a private thing, at least one, that is my member variable that I don't want the user to touch. So that's my count. So every time you make a counting device, it has a count inside of it, and that's separate from anybody else's. That's your own member variable. So that's counter C. And then the operations I want are all of these: init, inc, reset, and get count. Boop. So let me clean this up. Oh, this is gonna need a semicolon eventually. Yeah, let's give these types now. So it's gonna be void init, void inc, void reset, and then it's just gonna be int get count, right? That's the one thing that gives something back to us, isn't it? So I got all those guys. And I think that's a good starting point. Let's implement them outside of the class again. Boop. And we'll do init, and this is counters init, counters inc, counters reset, counters get count. They're methods. They're not just functions. Because they're going to look like functions in C++ if it didn't put that colon. So all right, for init, what do we do? Let me split screen this so you can see the declaration of the class too. So init means just like 0 out the count. Make the count 0, and then inc should do count plus plus. Reset should set the count back to 0, and it's technically like init, right? Just a new name, because init's supposed to only happen once in theory. That's what we're gonna promise to do. And then get count gives back the current count inside of the counting device. Yeah? So those are all the things. And it's running, and my code is trying to print, and it's a very complicated program that prints 3 and then 1. Yeah? Let's see if it does it. We got the 1. Did we get the 3? Yay! Awesome. Okay. So that was great. That is progress. That's what we want to see. And that's perfect. So we got a counting device that's working. It seems to be working. If we don't trust ourselves, we can make tests, and we can do that later. But let's see. What do I want to do next? In my notes, I made a reset method that just lets you spin the dial to anything. So let's let reset like take something. Like reset it to 42, please. And so this is going to take a new count that's that you want it to be. And so we need to change that here too. And one thing you can do though is you can have this be a default. So you can set that new count to 0. You can only put this in one place, by the way. And so if I can't say equals 0 here as well, you can only say it one place, and I think the best place to do it is in the declaration. But this is called having a default parameter. Maybe you've read about that, maybe you haven't. But this is a default parameter to reset, so that if you didn't give something, like it's new count, now we're always going to have this argument here. But if you didn't give something, if you passed along nothing, then new count will be set to this default of 0. But if you pass something, then that's what you get. So let's get rid of that again. And this is going to work still. I still get my 3-1. Does that make sense? Because this reset is expecting something, but if I don't give something like I didn't here, it's getting the default value. That's what default parameters are all about. So I'm setting it to 0, just as I was before. But if I actually pass something, if I pass 42, now I get whatever I really passed. That takes precedence, of course. That takes priority. So then I get 43. Does that make sense? If you haven't seen it before, hopefully it's kind of self-explanatory. That's a default parameter. If you don't give something for new count, you just say reset parenthesis parenthesis, then it's just going to give you that default of 0 that we placed there. And you can only have a default in one place, and the reason C++ enforces that because you might accidentally just do that or something. And so now it's like, which one do I trust? So it only lets you do it once. And we're going to do it in the declaration. So yeah, that's the reset. I think that's more or less what I wanted to say. That's my first bit of counter examples. And now remember, we had to always call init. You make a new counter, you always have to say c.init because otherwise this count is going to be set to who knows what, garbage, whatever was in memory at the time. If I forget to say init, it's undefined behavior, and it just happened to be 0 for my compiler for my operating system. But if I ran this on the class server, for example, it probably would have been like, it would have printed garbage. It would have incremented garbage, right? So you can't bank on it being like zeroed out for you or anything. So yeah, let's make it so that we don't have to remember to call init. That's where we're going, all right? I don't want to have to remember to call init because I don't trust myself, and you shouldn't either, right? So a constructor is the answer. All right, so a constructor is a way to have a method that's always called for you when your object gets made, and you can't forget because it's called for you. All right, and what a constructor is in C++, this is similar in many languages. It's a method with the same name as your class, but there's no return type. All right, it's just you say the name of your class, put some parentheses, maybe there's parameters involved. But a constructor is a very good place to initialize all of your member variables that need initialization because a constructor is guaranteed to get called for you, all right? You can have multiple different kinds of constructors, and I'll show you that. But let's get rid of our init function and turn it in, init member function or method. It's not just a function. Let's get rid of that, and then we will turn it in to a constructor. And it's always going to get called for you either implicitly or explicitly. There's something called a default constructor. That's a constructor that takes nothing. I'm going to show you that one first. But there's also a way to call a constructor that like takes something. Like you can ask for arguments, ask for parameters. So let's make it so that we don't need this init by making a constructor. Let's turn this into a constructor. All right. So instead of init, I'm going to make a constructor, and the name of your constructor is the method with the same name as your class. So if this is the class counter, my constructor's name is going to be called counter. There's no return type. And for a default constructor, there's no arguments. There's no parameters. This is called the default constructor. All right. And this is going to get called for us, and I'm going to get rid of init. I'm going to turn this into the constructor. Counter's counter method. But there's no return type because constructors are weird. This is the constructor. This is the default constructor. Does that make sense? This is just its implementation. And the way that you call a constructor, I can get rid of this call to init down here now. The way that you call a constructor is just declare the thing. By saying counter C semicolon, it implicitly calls the default constructor for you. That's really nice. If there is one, and we made one now, just by saying this syntax, by making anything of type counter, giving it a name, putting a semicolon. You didn't pass anything in this line, but this is the line where it got created, so it's calling the default constructor, the constructor that takes nothing. All right, so this implicitly calls the default constructor. If you don't believe me, I'll say I'll see out that we called the constructor. All right. Isn't this fun? There it is. It's happening. We're getting called just by having this line, and then it's inking properly. Everybody's happy. Isn't that great? That is what a default constructor is all about. You can also have a constructor that takes something. So constructors always have the same name as the class. So I can also have another constructor called counter, but it needs to be differentiated in some way. So I can have it take something. Let's say that another way to initialize a counter is to pass along like what you want its starting count to be. Yeah. That would work, like spin the dial to whatever you want. Take it out of the package, buy it where it comes in 42 once you open the box. This is called a parameterized constructor because it has a parameter that it declares. And so I haven't shown you how to give it a parameter. Maybe you remember from the previous class, but let's implement that one. Int starting count. This is the parameterized constructor. And the count needs to be set to whatever you pass, if you call this one. It's only ever one constructor that gets called, though. All right, only ever one constructor gets called. And the way that you call it, if there's a constructor that takes something, you need to somehow, in a line that looks like this, where you're making a counter, you have to pass something. And here's the secret. Here's how you do that. Instead of saying, like, here's counter C2, if you just put a semicolon, you're getting the default because you didn't call it, right? You gave no arguments on this line. But there is a place to give arguments. It's a weird kind of looking place, but it's like you call the name as a function. This is me passing along an argument to the constructor, all right? So this will call the parameterized constructor. It notices that I passed along an int. It looks weird, I know. If you haven't seen this before, it calls the parameterized constructor. And so now C2, its count will initially be set to whatever I pass, this 42. See that? Technically, you could have made this one big thing by using default values, kind of like we did for the reset method. You could have combined these by saying like int starting count equals 0. And then it's like both a default and a parameterized constructor. But I want to do that right now because that would just be more confusing, I think. So we can keep them separate. This is totally fine. So this is calling the parameterized constructor. The count will be set to 42 for C2, and then you can play the game of using it still. C2.inc a few times. So now the count in C2 is 44, and if I printed that, we can confirm it. And you can write some tests if you're not confident enough, but there's my 44 printed out right down there. That's beautiful. And we're calling the parameterized constructor. It knows. It knows and it found that one. All right. So please yell at me if you have any questions about this stuff. This just keeps getting built on top of. So please make sure to ask questions early, practice early. Yeah, that's that one. And let's see, what do I want to do next? I want to say something, this just keeps getting weirder. There's something called the default constructor. They really don't make it easy in C++. So if you don't make all this is if you don't make a constructor, C++ will make one for you. It's going to be a default constructor. It will make it in its default way. And what it will do is it will call the default constructors of all your member variables in the order that they're declared. That's all it will do. Just remember those words because we're going to come back to it later and it's going to matter. But right now it doesn't really matter. Just want you to have heard of this. All right. So the default constructor, if you don't make one, like you didn't say, hey, I'm making a counter default constructor, C++ would make one for you and it would call the default constructors of all your member variables in order. Though the default constructor for an int is just like set it to garbage, do nothing at all. Some things do have default constructors. Vector is the best example that I can think of right now. So like, you know how when you make a vector, you can say vector int v semicolon and that makes it empty? That's the default constructor on vectors. So if you had like a member variable that was a vector, it would get default constructed. Does that make sense? To be empty. But there's other kinds of vector constructors, and maybe you've seen those. Maybe you've learned to be like, you've heard of this one. This is called the fill constructor for a vector. This is a constructor call, right? This is saying, hey, V, initialize yourself to hold 142s. So the vector is going to be 100 long, and it's going to hold 42 in every index. This is a default constructor call. This is a parameterized constructor call for vectors, okay? And so if you want, if you just have a bunch of classes and things and ints and things and they don't really matter, you're fine with the vector starting empty. Like you just make all of your member variables as they are. Don't make a default constructor, and the default one takes over. All right. I know that probably didn't make a lot of sense. Just remember this phrase. All right. The default constructor will default construct all of your member variables in the order that they're declared. That will matter one day. All right. But what if you have a vector, like you legitimately have a vector member variable, and you're like, I want to call this one. I want that vector when I get to my constructor, like I'm going to make my own constructor, I would like this vector to hold 142s. Like I want to do something like this, v 142s, where v is declared up here, right? Like I want that. Sadly, it's too late to be in the body here. Sadly, v has already been constructed by the time you get to the body of your constructor. And so if you want to fill construct it, if you want to call the constructor for your vector member variable in a different way, you don't want the default, you got to do it somewhere before the start of the body of your constructor. All right? Again, this is very weird stuff, but it will become useful one day. That's called, the way that you do this is you use what's called an initializer list. So you're forced to use an initializer list if you want to call some non-default constructor for a member variable, all right? And the way it looks is you do this sad face. Before the body of your constructor, this is like example class with a constructor, you put constructor calls, and you can comma separate them. All right, I'll give you an example. This slide, I know it's hard to put this into words without an example, so I'm going to give you an example in just a second. But yeah, the idea is it's way too late. This is too late. Your vector v has already been default constructed by the time you get to the body of your constructor. So if you want to call the fill constructor, you got to do it in the initializer list. That is the moral of this story. That's all I'm trying to say. All right. So yeah, constructors are called for your member variables before you hit the body. You must use this thing called an initializer list if you want to call a non-default constructor for your member variables, all right? It's silly, but that's all you can do. That's the only way to call a constructor on a member variable like a vector that is itself a class, that has different constructors, all right? Also, if you have a const member variable, which you can set it to a different constant thing in the initializer list, all right? So the sad face is the secret. Let me just show you this quickly. I know it's weird, all right? So if I want 142s in my vector, and that's the way I want to fill this vector, I want to call that fill constructor that looks like this. I want to have this portion right here. I put a colon. I know it looks weird. I put a colon, and then I say I would like 142s, please. Does that make sense? Now the vector, by the time I hit the body, I have 142s in my vector. That is me calling the constructor I wanted for vectors. I know that's weird, all right? But that's where you put it. That's your initializer list, okay? And so, surprisingly, you can use constructor style calls to set like ints. It's like instead of saying int count equals 0, you can also say int count 0 like this. These are equivalent, weirdly enough. And so I can put this kind of syntax in the initializer list and set the count member variable in that way. So instead of saying count equals 0, I could do this. I could say colon count 0. I'm constructing the count member variable. Isn't that weird? And so you do that. So this is for, like, let's say I want to, maybe I want the vector to be empty in this one, so I just don't say anything. The vector is default constructed. But maybe here I want 142s in my vector. Yeah, does that make sense? So yeah, that's that. So because I don't mention the vector here, it gets default constructed. So the vector is empty. All right, so it's empty. Crazy enough. But here I've actually said, hey, no, vector, I want you to be something special, please. All right. I can also set the count in that way. So I can be like count. I want the count to be the starting count, whatever I pass. So count, starting count. And if you want to set a bunch of things with constructor style calls, you just put a comma between them before the body. And if I didn't have these cout lines, legitimately, this could be empty. All right. If I didn't have the cout, and it would be okay. The body of this constructor could be empty. I did all my setting before the body happened, and that's fine, okay? The body could be completely empty, that's okay. But I'm gonna keep the cout lines for fun. The other thing that you need initializer lists for is if you have a const member variable, weirdly enough. Const double D. So you know that const stuff, right? You can set it once and you can, it's going to stay set that way. But you can have a different value for your const member variable wherever you want it. It's too late to say D equals 3.14 here. It's already constant. It's already fixed at that point. But again, the initializer list, you can set it there. So I can say, hey, I want that D value to be set to 3.14 here. Use that constructor style call and it's been set. Or, and actually for a const, you're forced to set it to something in every single call. So like maybe you can set it to a different value here, 5.67. And so now this D member variable, depending on which constructor you used, holds a different value, but that value cannot change. It has been set here in stone. It can't change for the life of your object, but it can be a different value and it can be computed in the constructor. That's crazy, all right? And called in this way in the initializer list of your constructor. Okay, so I know this is weird and contrived, but that's kind of the idea, all right? So yeah, for this vector v, kind of the idea is default constructor called automatically unless you change it. And this is how you call a constructor that you want, right? You put it in this initializer list. You put this colon, make the sad face, and then you start giving constructor calls. And you can comma separate them before the body of your constructor, okay? And so here I am. Hey, vector v, I want you to hold 142s. I don't want you to just be empty. Whereas for the default constructor, I am not mentioning v. So v is empty. It gets default constructed if I don't mention anything. That's something that the default constructor would have done for me as well. Okay, so this is a lot of words. These are weird things. Search them. Go back to your CSCI 40 textbook. It should have a section on this. Yell at me. Yell at your peers. Come to office hours. Go to the tutorial center. We will get you through this. All right. I know this is weird if you haven't seen this before, but we'll get there. Okay. So let's see. What do I want? Your turn. How about this? So let's say we got this class. We got a class point, and the idea of a point is to like be like a point in the in two-dimensional space. So let's say I want to represent the idea of like a 2D point for like where the enemy is in a game. It's at x equals 3 and y equals 5. So I want you to use initializer lists and make a constructor for the point class so that I can declare a point P having x being 3 and y being 5. So I want a constructor placed here and also give me an implementation of how to set the member variables. All right, in this style of way, do it within an initializer list, please. So let me give you all this code as well. So here is, you're going to want a parameterized constructor, all right? But your class is not called counter anymore, is it? It is called point. So there's that, and then here is the parameterized constructor for at least the relevant pieces. Oh, that can all fit, perfect. For counters. So try to do this for points. Make it so that you can say this line and have it run a constructor that's parameterized to set x being 3 and y being 5 using initializer lists. This is a great test. Go off, code it up. All right. So what constructor needs to go here? Well, it's called point, right? It has to be called point. So I'll say point. And then it's taken two things, x and y. Sometimes you don't want them to clash, so you can be like x value int y val or something, like that would work. But there is a way, initializer lists actually let you get away with this in a cool way. So let me show you that. So here I am, I'm using the same name as my member variables, and this won't actually be a problem if you use initializer lists. If you don't use initializer lists, this will be a problem, but this is fine. And then the implementation is, all right, it's point, : point. It's points, point member, member function. Points, point method. And it took an x and a y. That t looks weird, int x, int y. And then initializer list, : sad face, right? I want to set the x member variable with a constructor style call for the initializer list. The first thing you say is always the name of a member variable. So it's not ambiguous. Like, am I talking about this x or this x? It's always going to be your member variable's x. Set it to what? And then this is where the other one takes precedence. And so this set it to the x that was passed to me. So this looks weird. And then do the same for y. My y member variable, set it to the y that was passed to me. If this looks weird, you could have called this y val. This could be like y, set it to y val. but there is no ambiguity if you use initializer lists, which is cool. And that's all you wanted for the constructor. So you still need to give curly braces for a body, but the body can be empty. Isn't that neat? And that will work. Then your X and your Y have been set properly, and this line will run just as you want it to. That's really fun. Please try this out. Please compile and run it. Use the point in some way, like program the Pythagorean theorem or something to make it work and see that it's worked. Or just at least print out the X's and the Y's. See that it happened. That's a great thing to practice with. So yeah, that is a good start. And so yeah, we have some cool things for our counter class now. A constructor is very powerful, right? It's a method that gets called for us whenever we create our object, either implicitly or explicitly. We're getting somebody called, all right? And that's great. The next thing I want to talk about is something maybe you've learned about, something I teach in my CSCI 40 classes. It's called const. You can apply const to the end of a method, okay? So it's a little weird looking if you haven't seen it before. It's going to look wrong, but it's a great thing because it makes sure that you're not messing with yourself, all right? Make sure that you're not going to do something weird in your own method implementation. So this is marking an entire method as const. It's not the same as like making a const reference parameter. We like those too, but those are just making sure that that particular variable that you passed as a const reference isn't being messed with. Const at the end of a method is making sure that none of your member variables are going to be messed with, all right? Const member functions, const methods are for when you want to make sure that you, in the body of your method, that one that you're declaring as const, you're promising that you can't touch your own member variables, all right? So it's like a little sanity check. It's like, all right, if I'm supposed to give back a value, this makes sure if I mark it as const, I can't accidentally set the value, all right? So let's run through some of our methods here. So like which ones are not supposed to be messing with our member variables, just looking at them or using them, all right? So constructors, always gonna mess with a member variable. So those don't be const. Those don't need to be const ever. Inc, messing with count, can't be const. Reset, messing with count, can't be const, but get count. Every getter, every sane looking getter must be const. Does that make sense? Get count, if you look at it, it shouldn't be allowed to say this, right? That would be wrong. That would be horrible. That's not the essence of getting the count is not setting the count, yeah? So it should be marked as const so that this won't even be allowed anymore if we did that. If we marked it as const, we wouldn't even be able to have that line compile. And that's great. And this is what you do. You say get count const, int get count const. And by saying that, now you got to put it in the implementation too. It's part of the name. This is not just normal int get count, it's int get count const. And by putting that const there, it marks the entire object as read-only for the duration of this call, which means that you cannot write to it. So messing with your member variable, this won't even compile. All right, so can you understand this error message? Can't assign a non-static data member within const member function. All right, it's declared const. That's perfect. That's what we wanted. Does this say anything different? Yeah, assignment of member in read-only object. So it has a different style of error message here. Both are useful. So it marks the entire object as read-only for the duration of this call, and that's the whole point of getters, right? A get count method should never be able to mess with your member variables. That's not what it means to get something, right? So that's great. That makes sure that we cannot do something silly like that, and that's what const is for. It's just a sanity check for you, the programmer, to make sure you don't accidentally do something silly, all right? And as programmers, we are known to do silly things sometimes. So it's good to just make sure to give us as few ways as possible to mess up. So that's a const member function. And yeah, let's see. Before I get into the last topic, I want to just do something in between. And I want to talk about pointers, because pointers are going to come up so much in this class. Unfortunately, I'm sorry if you hate them. We're going to get very used to them. We're going to learn to love them. But if you haven't seen this before, you can make a pointer to an object. So let's say I make a counter object, and like I can mess with it a few times, like ink it twice. Now the count's 2, of course. You can make a pointer to a counter. That would be a counter star, right? And then you can give it the address of your counter object. So say that this counter lives starting at address 100, then this C2 then would hold the number 100. That's its window, it's its address of C that it's pointing to. And we would like to be able to like use C2 to get to C and run methods on C. All right, so I want to just remind you of all that. So I'm getting the address of C, that's 100, and I'm placing it in C2, and that sets up this pointer-pointee relationship. And C2 is holding the address of a counter. So it's a counter star, that's its type. Okay, so it looks weird, it's not like int star or anything, it's counter star. You can totally have that. And I just want to teach you how to call the methods on starting at C2, how to get to C. All right, because there's an arrow operator that I want to make sure you've seen. All right, if you haven't already. So I guess I want to do this in main. Just for fun, I've got this C, right? I've got this counter C. I've also got this counter C2. Let's make a pointer to a counter called, it's going to be counter star as its type. I'll say C pointer. Let's make a pointer to the C object, this original C object up here. And so set it to the address of C. Cool. And so now C pointer is holding the address of C, whatever it happens to be. All right. And let's say I want to use C pointer to get the count of the C object. All right. So I want to use the C pointer to get to the real C object that it's pointing to, like follow that pointer, go to that address, get to the count. All right. So what I kind of want to do is I want to like follow it, C pointer in some way to get to the actual C object pointer. And then on that actual object, I want to say .get count and then see out the thing. That's what I want. How do I do that? Might be the question. I guess is the question I'm forcing you to think about. So what you can't do is this. You can't just be like C pointer .get count. Do you see? Do you see why? It won't compile. It will have a very helpful error message. But think about what C pointer is. Is C pointer a counter? Think of it as C2 in this diagram. It's not, right? C2, C pointer is just a number. It's just a number. So this is us kind of saying 100.get count, which makes no sense at all. Does that make sense? So it's not getting you to the right spot. If you want to get to C through a pointer to C, you must follow that pointer. You must dereference. So only after dereferencing star C pointer, right? That goes to the actual C, because C pointer is pointed to C. It follows the pointer, gets to the actual object. And then we have an object that has a get count method. Yeah? So that's one way to do it. And the parentheses are unfortunately necessary. Totally works. So there's my 43. That's fine. The parentheses are necessary for weird precedence reasons. Otherwise, it thinks you're trying to dereference. If I didn't have these, it'll think that I'm trying to dereference this entire result, which is not itself a pointer, unfortunately. So you got to keep these parentheses here, or everybody hated this, and so they invented the arrow operator, which does the dereference and the dot at the same time. So this line is equivalent to this line. So instead of that, you say arrow. C pointer arrow get count. This does the dereference and the dot at the exact same time. These are equivalent lines. This line and this line do the exact same thing. I get my 243s. Okay, so that's that. And I think that's what I wanted to say. So this will become useful and necessary to remember later. But that is what happens when you have a pointer to like any kind of object, either a struct or a class. If you got a pointer to that thing, you have to follow it to get to its members. All right, you can't use the dot just yet. You have to follow the thing, get to the actual value that is an object. And then you can do the dot. And the arrow operator does both at the same time. Okay, well, that's that one. And yeah, we've learned a bunch of things, or we've been reminded of a bunch of things about classes if we've seen them all before. But let's just put it all in one slide so we can remember. All right. So here is how far we've come. Right. This is what we need to remember when we're making classes and we're programming using object-oriented programming. So step 1, make all of your member variables private, because you don't want the user messing with things. Like we want to make sure that the count increments itself using inc, and maybe reset is we're letting it reset things in a normal looking way. But that's giving the user just as much power as we want to give them. We don't want to let the user just like set count to whatever they want. We don't want the user to set v to whatever they want. Okay. So we can make getters or setters as much as we need to, and those are just methods. make a method that gives back what we want, make a method that sets what we want in a way that we want it to. So maybe like say that reset is something we could ask the user to call, right? And it will set our count. Maybe we can, maybe we never want the count to be negative. Do you see how you could add an if statement to this body and force that count to never be negative? Whereas if we marked count as public, then count could easily become negative because the user can do whatever they want. But if I added an if statement to this is called a setter, right? Because it's setting a value. It would easily like protect against any issues and making count be something wrong. So that's good. That's the whole point. So by making your member variables private, you can give just as much access as you want to the user. So there's that. You should also be writing constructors that initialize all of your member variables, or if you know like this vector, I just want it to be empty, you can, to leave it alone. All right, just if you have a bunch of ints though, set all of your ints. All right, initialize all your member variables. Understand if you're purposefully default constructing some though. Okay, so that's you using your powers for good. And then also make as few methods as possible public, because what the user gets to do is all the public stuff, right? The user gets to call all of these things. If you give it something very technical and something that kind of like messes with the class in a way that you don't want them to, it probably shouldn't have been public. You can make a private method that's just yours that helps you implement other ones. That's totally fine. You can call it within the implementation of another method, but anything public the user can use, right? And that may be a bad thing. So make as few methods as possible public, because we don't trust the user of our class, right? Also make as many methods as possible const. So the more const methods you have, the fewer can mess, the fewer of them can mess with your member variables, right? So const marks the entire object as read-only for the duration of the call, and certain methods, like getCount, should be marked as const so they don't accidentally do something bad to your member variables. If you have a method that could be marked as const, you should mark it as const, all right? Because who knows if you'll come along and you're very tired one day and you'll accidentally set something, the compiler will like save you if you mark it as const, all right? So there's that. And then, yeah, another thing that I didn't really talk about too much in this example is you should be using references as much as humanly possible. Pass around const references if you can, or just a normal reference if you can't, to save copies from getting made. All right, we'll talk a little bit more about that later, but that's useful. Go back to like your CSCI 40 textbook. Remember what a reference is and a const reference is. It's very, very useful when you're passing things around to keep things from getting copied. Yeah, with ints, it's not a big deal, but like if you're passing a vector along, you should have passed that as a constant reference, all right? And then finally, something that we talked a lot about last time towards the end was testing things, right? Test all of your member functions as much as you possibly can, because the more tests you write, the more confident you can be that your implementation is correct, all right? So keep all that in mind, and yell at me if I ever forget something, right? That's the whole point. We want a bunch of eyes. It's pair programming. We want a bunch of eyes on all the code that we write, even the code that I write. I'm not perfect. So that's why I mark all the methods as const as much as I can. So I don't trust myself. Let's next talk, and this will be the last topic for the day, I think. Let's talk about operator overloading. All right. So operator overloading is a nice feature of C++. Some languages don't have this. I'm looking at you, Java. You can make a plus operation for whatever types you want. So plus normally like uses two doubles or two ints or maybe an int and a double, and like plus also works on strings, right? Two strings makes a third string. Let's make a plus that takes two counters. We can do that in C++. It's very nice. So let me show you how to make operators. And so like I want to be able to do this. And I'll show you how to make it happen, but let me give you the example first. Let's say I have two counters. I've got counter C and C2, which I have right now, and I want to be able to add them together, making a counter C3. Does that make sense? So I like this, and so like I've got my counter C, I got my counter C2 laying around, and let's say I want to add them together. Let's see, let's say that C is holding 2 and C2 is holding 3. let's define, we have to define what it means to add two counters to make a third counter. Let's say that to add two counters just kind of adds up their counts. That's a sane thing to want to do. So let's say if I add two counters, it makes a new counter with the count set to 3. Or sorry, 2 plus 3, excuse me, which is 5. So I get 5 out of the deal. Does that make sense? That's what I want. And so I need to tell C++, hey, I know how, if you see a plus and you see two counters on either side, I know how to add them. Here's what you do. And it will give back a new counter because I'm using that type here. So this syntax is not the end of the story. There's some secret sauce happening underneath the hood. So what C++ goes and looks for is one of two things. You could make the plus operator, it's called overloading operators. We say what we want the plus to do. It's an overloaded version of the plus operator for counters. We say what we want to have happen. You can either make this plus operation, you turn it into a function or a method call is what's going to happen. You can turn it either into a function call or a method call. And so C++ will look for one of two things. Either you've made it inside the class or outside the class, if it's classes that you're adding together, objects that you're adding together of that class. It's either going to look for, if it's plus, it's going to look for something called, it's not, you don't just be like int or counter plus. It's not a function called like this. It would look weird. It's not like called counter plus and it takes counter 1, counter 2 or something. The name of this thing is not actually plus. It's called operator plus. So it still has the plus sign in its name, but the full name of the plus operation to C++ is called operator plus. Okay? So if C++ sees you adding two counters, it's going to go looking for an implementation of either. It's going to try to turn this code into either a method call, C dot operator plus, where the first thing is like a call with C2 as the argument, or let me make this as legible as possible, or it's going to go looking for a function call that's just called operator plus out in the open that takes both things you wanted to add, C and C2. C++ will try to call either this thing or this thing when it sees this. Does that make enough sense? It's going to go looking for one or the other, because if it's an object, this could have been a method on this first object, so it'll either try to call this one, or it'll go look for an operator plus function just outside of any one of the methods of the counter class. So either way, as long as you implement one of those, if you implement both, C++ will get confused and worry about which one you wanted, so you can only give one, but let's make this one inside the class. Let's make it be a method, and as long as I implement this method called operator plus that takes myself and somebody else, and it returns back a new counter, this line will run. Isn't that so cool? So to C++, every operator under the sun, like plus, minus, times, divide, all of them, they're just either functions or methods. Their names look like this. It's operator and then whatever the operation was. Operator plus, operator minus, operator star, operator slash. That's pretty cool. So let's make the first one as a method. All right, so let's do pluses. It's cool. So I want to be able to do this. Counter C3 equals C plus C2. Isn't that great? And so, yeah, so let's just spell this out to remember. So when you say C plus C2, the compiler, G++, goes looking for, it tries to call either the function operator plus with C and C2, the two things together, or it tries to think of it as a method call with the first thing first and then C dot operator plus on just the other thing. All right. And so for us, we're going to do that second one. And so this is going to end up being secretly translated to C dot operator plus on C2. And then if I print out C3's get count, it should hold the summed count of C and C2. We'll get to that. All right, so let's implement this now. Let's implement operator plus as a method on counters. So it's operator plus. It takes ourselves, right? We got it. This is being called on us, and we're getting some other counter. So counter other, and it's returning back a third counter. So it's us plus somebody else equals some third counter. Does that make sense? So some cool things to realize here. This other counter, we're just looking at its count. So this could be const reference. We're using our rules. And then we're also just looking at our own member variables. We're not messing with our own count, so this can also be const. We're filling in a third counter's count member variable, but that's not us. That's somebody else, so this is fine. It's totally const. So there is my operator plus. And so let's implement that. Whee! And so this is going to be a little unwieldy, I know. This is counter ::operator plus method. Takes ourselves and some other counter. All right. And we're adding our own count to somebody else's count. So this is called, right? Called when we're supposed to add our count to or with others count. And this is within the counter implementation. This is within the counter class, so I can say other.count just fine. Even though it's not my own count, it's still part of the counter class. I can use member variables. I can access private things because I'm within the class implementation still. And so I've got this new counter, let's call it res. I'll fill it up and then I'll return res. How about that? Okay. And so I can say res.count equals my own count plus others count. And so I can mess with member variables. I could have just said res.reset to this thing. That would have also worked, but I'm allowed to mess with member variables. That's okay. I'm within the counter class. And this will work. Isn't that so cool? So let's do this kind of split screen. There's the plus. Here's the call. What happens if I do this? There we go. Counter. I think C was 43, right? For C, and C2 was it also? No, it was 43 and 44. And so it's 87. Isn't that fun? We're also constructing this guy as a default constructor call. That's fun to think about as well. So yeah, that's that. And this is us giving meaning to the plus sign. It calls this code. Isn't that cool? It's translating it into this kind of call. It's called syntactic sugar. It makes it look sweeter than it would have normally. But this is getting turned into this kind of call. It's hidden up here with with C as the implicit object that I can just say count and talk about. And then other is the C2. It's calling it in this way. Okay? That's so fun. It's so useful. So that's what's going on. And you better believe you can do it with any other counter. You can do this with any other operation for counters. All right, so let's do a star operation that combines two counters. Again, we can make it inside the class or outside the class. Let's do this one outside, just as a normal function. All right. So yeah, let's do that. Boop. So let's make a call to a multiplication operator on counters. Be like, hey, C4 equals C times C2. And let's just say to multiply two counters, it means to multiply their counts again. So this one will either call operator star C and C2, or it'll call C dot operator star on C2, and we want that first one. Let's have it do this one. Okay, so let's give this as an implementation, and in theory, we'll get another answer. So let's do a star. That's going to be operator star. Takes two counters, C1, or maybe I can call them A and B. And again, it's just looking at their member variables, so these can be const. And it returns back a third counter. It's a counter holding the count that is the multiplication of the inner counts, right, of the A and B's counts. So, yeah, if you do it this way, if you do it in a similar way to this code, this is a function. It needs to be a friend, right? This is A's count, and this has got to be B's count. If you do it in this way, you can't do B.count. You can't do A.count. They're private, right? This is not a method of the counter class. It's just a function. So if we want to do it this way, this must be marked as a friend of the class. So we can go up here, we can declare that it's a friend. Friend, it's happy. Now I can use it. And that's fine. And that's kind of cool. So there's that one. I don't know why it does that every time. So here I am doing the star, and here's the code that's going to get run. It's going to pass CNC2 into A and B, and it's building it up this way. And this is just a function. So I had to, if I'm going to do .count, get private member variables, I have to mark that as a friend of the counter class. So there's the multiplied counts together. That's working. And so that's one way we could have done this. We could have gotten around this by not making it a friend, because we have like get count and reset, right? So that's like, this was option 1. Whee. This is option 1. Option 2, you don't have to mark it as a friend if you don't want to. You could have done something like this. You've been like, all right, counter res is a counter holding the following member, holding the following count, A's get count times B's get count. I'm only using public things, return res. See how that would have also worked? And it didn't need to be friend in that case. So either one's happy. So there's that, but we can mark it as a friend for fun. And then literally every other operator, you can overload them all. All right. You could say what it means to multiply a counter on the left by an int on the right, right? Because like here it was 2 things, counter and counter. I could have put an int here. And now you're saying what happens when you multiply a counter on the left by an int on the right. And that's fine. Do whatever you want. So here's like a list of a bunch of different operators. They're all here, right? You can overload any of these guys. Yeah, plus, minus, star, modulus. What does it mean to take the address of your thing? Or I guess this is also bitwise and. What does it mean to compare for equality, disequality? What does it mean for one counter to be greater than another, less than another? All of those things, they're there. And I think there's probably more at the bottom here. Some weird looking ones like plus plus a counter, minus minus a counter. What does it mean to negate a counter? All those things, you can overload all these guys. It's so fun. You have all the options, all right? So look into that. And the last operator I want to show you is a useful one. It's called the output operator. So wouldn't it be nice, because I did this all over this program, I kept couting, right? I kept couting C4.getCount. That was just a lot of typing. Wouldn't it be nice if I could tell cout exactly how to print a single counter object? Wouldn't it be nice to do this? Hey, cout, take C4, print it. This doesn't work right now, of course, because cout has no clue what to do with a counter if I give it, if I give something to it. Let me show that to you, and let me show you the weird error that you get. But cout C4 and a new line. I'm gonna get a weird looking error, and it's gonna be very long. It's very unfortunate. Scroll, scroll, scroll. But do you see what it's saying? Operator less than, less than. What is this but an operator? Because when I do this, when I do like this first part, what's it doing? It's turning this into a call that looks like this. Could be a method, could be a function. We cannot implement cout anymore. We can't add to its class. So we're kind of forced to do this as a function. But like, this is what it's trying to call. It's trying to call operator less than with cout on the left and C4 on the right. That's this first output. Does that make sense? So if I gave meaning to that, if I said what it means, like if I gave this implementation, then cout knows how to take, right? It knows how to take using that operator, a counter on the right. Isn't that amazing? That's really fun. So we can give that meaning. We can totally give that meaning. So like if you say this gets turned into this call. Operator less than, it's called the output operator, with cout on the left, because that was the first thing, and C4 on the right, because that was the second thing. That's what it's turning into. Those are your 2 things. And so what we need is to declare then one of these guys that returns back the right thing, that takes cout's on the left and see your counter on the right. And so like you put whatever type you want over here, that's like counter, constant reference to a counter or something. And then what is the type of cout, you might wonder? It is an O stream. Cout is an O stream, and I can prove that to you if you've never looked into that. Cout lives in IO stream, right? Cout. It is an O stream. Look at that. O stream. And an O stream is just a type that lets you like give stuff to it. So like it has that output operator inside of it. That's pretty fun, right? So that's the type of cout. And this is kind of what your output operator needs to look like. So it's got to take the type, it's got to take cout first. So here's the type of cout. You're going to take it by reference. You cannot copy the terminal, right? Because cout is kind of like the terminal screen. You got to take that one by reference, and you're messing with it because you're adding to it. So it's not a const reference, just a normal reference. Sadly, you kind of need to memorize this at the start, but you'll get used to it. And then you take your next thing, like this is your counter object, and you give back, you always return back your cout. And the reason we don't just like say cout here, you call it whatever O stream we were given, because you could also, this will work for files as well, because file streams, OF streams, are secretly also O streams. That's pretty fun, all right? So yeah, you return back your O stream, give back OS. So you can chain your less than operations, okay? So, yeah, that looks better on multiple lines. Otherwise, it looks like so backwards. So the reason you give back cout is because of this. When you run this line, because this is the line I really want to run, C4, and then a new line as well. This is really two separate calls to kind of cout, isn't it? It's like first cout this, first cout that, and then cout that as well. And the way that this works is because this operator gives back whatever the thing was on the left. So kind of the parentheses get drawn like this, that runs this first line first. And then as long as this first line, that cout to cout C4, gives back cout, as long as that returns cout, that's what the next operator sees and gives its value to. Yeah, that is supposed to be cout. So this will result in, after it prints C4, it will result in this cout just endl. So that's why your output operator must return the O stream that it started with, because you can just keep chaining things like that, okay? And so that's how that works, and it's very cool. And you better believe the same thing works with like cin. If you want to be able to cin into a like your counter, like fill in the count in that way, like call reset or something. You can cin from into like your counter. You can see it, you can read in from a file into your counter's count or something like that would totally work. It's just going to be, instead of O stream, it's I stream, right? And it's operator this way. That's really fun and really cool. Okay, so let me show you this for cout, and that will be the last thing we do today. So let's see here. Dun, dun, dun. Do remember to look at the lab assignment, because you should, in theory, if I'm recording all these things properly, there's going to be a lab assignment that you'll be able to see as well. And I'm going to have an introductory video for the lab assignment on the lab assignment page. Okay, so go and look for that as well. But for my last trick, let's program this. So let's do an output operator. It's gonna be this one. It's gonna look like this, and it's got to return things in the right way, and we'll make it work. All right, so it's gonna be operator less than, it takes cout first, which is an O stream by reference, call it OS, whatever it was, because it could have also been a file. Maybe I'm printing to a file. It would just as easily work. It's whatever kind of O stream we were given. And then I want it to have a counter as well. And I just want to look at the counter. So it can be a const reference. And then the output operator with an O stream on the left should always be given back, should always give back the O stream that it was, that we gave to it, which is of type O stream reference. Okay, so it's returning a reference, which is maybe a weird thing, but that's okay. And then our job is to print to that O stream however we want, make that work, and then also remember to hit that return type properly. So remember to not just like give up and return, but always return OS at the end. because you need to let it chain properly. So return whatever OStream you were given. This is not void, it's OStream reference as our return type. All right, so how do we want to print our counter now is the question. Notice that I'm not about to say cout. I'm printing to whatever OStream I was given, because maybe it was a file, right? It still works the same. Give it the count, colon, and maybe I'll say c.getCount. Because this is outside of anything. I don't want to mark this as a friend, the counter class. So just like do it like that. And then I want to be able to come along myself and add a new line to cout. And so I'm not going to break this line. Just print it just like that. Don't try to break the line. I'm breaking the line myself down here. Does that make sense? Like that's what I want. That's how I want to print a counter. And it works. And it works and it does it. Isn't that fun? And so that will work for any kind of line you want to do. C3, print out C3. And I think that's all. So now it's every time you give it to cout, it runs your code. It's going to jump up here where cout was the OS and your counter was the whatever you gave here. It's going to be turned into C. And then the way that we're printing it is we're saying count colon space and then the count of our counter. That's our format for how we print a counter to cout or any file, any OStream. All right. And that's so fun. The reason we return this is so that we can chain these things just like this. It's not just a bunch of lines that end right after we print the thing. We want it to be able to keep going. And so that's why we keep on returning the thing we were given. All right, the cout, the whatever OStream it was. Okay. And so this is a fun thing to play with. I would highly encourage you to try to get this working, maybe with this point example. I think that would be a good one to practice with. Go do some operators on points maybe, including an output operator, because that's a very important one. And I think that's all that I wanted to talk about today. So do try out this code yourself, maybe write some tests, and then go looking for the lab introductory video somewhere in this module. You should be able to find it. All right, it'll be there somewhere. And all this stuff is up for you to study in the code from class, so go look for that too. And I think that's everything I wanted to say in this lecture. So I'll see you in the next one.